Here's a review for the Pre-Cal Chapter 1 test. So these are sections 1 through 7. So first thing is we're going to describe transformations. So looking at this one, the plus 2 is on the outside, so that means it's going to be up and down, and it's added, so it's up 2. So that's A. And then B, looking at it, this plus 2 is on the inside of the square root, so that means it's going to be left or right. And remember, inside's always opposite, so it's going to be left 2. And then that minus 5, it's on the outside, so that means it's going to go down 5. Number 2, describe the transformations necessary for this reflection and dilation. So look at this, these are both on the inside. And it's a parent function of the absolute value, so we don't need to worry about what happens with the absolute value because it's already taken care of. So that negative 3 on the inside, that's a reflection. And because it's on the inside of the absolute value, it reflects over the y-axis. And then the 3, it's on the inside, so it is going to be a horizontal. It's not really a 3, it's going to be a 1/3. It's a compressed by 1/3. It's a horizontal compressed by 1/3. Number 3, we get to graph a piecewise function. Woohoo! So I'm going to go ahead and put where my windows are at. And I'm also going to kind of do this so I can tell which function is which. So I need a line at -2. And then I need a line at 7. Sorry, that was hard to see. And then I've got to draw each of these functions. This first one can only be seen when x is less than -2, so only in the leftmost region, and so it's a -2. That means it's going to open, or a negative x squared, so it's going to open down. And it would typically go 0 here and then come down like this, but we don't want it to show up in that middle region, so I'm going to erase. And this is not equal to, so on there it's going to be an open circle. I'm sorry, that's really bad. I can't do very well with this pen on graphing it. But it's that part of that parabola going down. And then we'll do the second one in blue here. It's y equals 3, so that's going to be in the middle region from -2 to 7 on the x. So 3, 1, 2, 3. And notice it's closed on the 2, and it is open on the 7. Keep this open over here. Alright, last, we'll do this function in purple. And the vertex of the parabola, because of the transformations, are going to be at 5, 2, and it's going to open up, and there's no change in the slope. So I'm going to go ahead and draw it. 1, 2, 2, right about there. And it's going to open up. So over 1 up 1, over 2 up 4. Here. And then if I went over 3, it'd go up 9. That's going to be off, I think. Yeah, just barely off. Up in there. So it goes up like this. And then I'm going to go back and erase the purple stuff in here. And this is also equal to at 7. So make sure it's a closed circle up there. Alright, number 4. This one's going to be a little easier. It says use this graph right here in the picture to graph this. So absolute value, it's around the whole thing and not around just the x. Since it's around the whole thing, it's going to be a reflection over the x-axis because it's a vertical reflection of anything underneath is going to go and flip up. So notice this is 1, 2, 3 down, so I'm going to go 1, 2, 3 up, and then draw up here. And I am going to go and connect that as if I would hit and then come back, and then of course it'd be here. That's the same, and then this bottom part of the line needs to be reflected up as well. So then it just goes up, and it needs to connect in purple. There you go. Number 5, I'm going to move this over to the side. It says find f plus g, f minus g, f times g, and f divided by g for f of x and g of x, and state the domains. So adding them up, we'll just add. So f plus g of x, there's no other like term for the 2x squared, so it's just 2x squared. And then we got a 4x and an x, so that's a plus 5x. And then a minus 6 and a plus 3, so it's a minus 3. Your domain on this one, there's no square roots, there's no denominator, so it's all real numbers. So negative infinity to positive infinity. You could have also said, in set notation, set of x such that x is an element of all reals. That's the same as well. Your call. F minus g of x. So there's nothing like the 2x squared, so 2x squared. Then we have a 4x minus an x, so that would be a plus 3x. And then a minus 6 minus a 3, so that's going to be a minus 9. And the domain on this one is all reals again, because there's no denominator and there's no square roots, so negative infinity to positive infinity. And then we have f times g of x. One more. And that we're going to have to distribute. So this is going to be a 2x cubed plus 4x squared minus 6x plus 6x squared plus 12x minus 18. Combining my like terms, I get a 2x cubed plus 10x squared plus 6x minus 18. Again, no denominators, no radicals, so my domain is all real numbers. One more. This is going to be the division, f divided by g of x, f divided by g, f of x divided by g of x. And so we have a 2x squared plus 4x minus 6 all over x plus 3. But we need to see if the top will factor, and it does, so it's a 2x minus 2. You're going to add an x plus 3 all over x plus 3, which reduces here, and so f divided by g of x is 2x minus 2. And on this one, your domain is that because of your denominator right there, that x cannot equal negative 3. So you can write it as negative infinity to negative 3, or negative 3 to positive infinity, or you could have written it in set builder, set x such that x does not equal negative 3, and x is an element of all reals, and close it off. All right, number 6. We're going to find f of g of x, g of f of x, and f of g of 6. So here we go. F of g of x, we're going to take that g of x equation and plug it into the f of x. So I'm going to take this and I'm going to plug it in for each of the x's. Don't forget, it needs to go in for all of them. So this is x minus 5 squared plus 2 times x minus 5 plus 8. And this is going to be an x squared minus 10x plus 25 plus 2x minus 10 plus 8. And that comes out to be an x squared minus 8x plus 23. So that's f of g of x. Now let's go find g of f of x. So I need to take the f of x and plug it into the g. Anywhere I see an x. So this is going to be an x squared plus 2x plus 8 minus 5, which gives me an x squared plus 2x plus 3. And then last but not least, we need to find f of g of 6. So you got two options. You can plug 6 in for g, and then whatever you get, then you plug that in for f, or you can just go and use this nice little equation right here that we already came up with and plug in a 6 there. So this is a 6 squared minus 8 times 6 plus 23. Simplifying that, that comes out to be an 11. All right, number 7, we want to find f of g of x for these two functions. So I need to take the g equation and plug it into the f equation where the x is at. I'm going to plug that 2x minus 6 in for that x. So it's going to be 1 over 2 minus 6 minus 3, which gives us a 1 over 2x minus 9. All right, number 8. Find two functions. This one's a little tricky, such that h of x is equal to f of g of x. So we need to figure out what we're going to do first for g of x. And I'm going to go ahead and make it what's underneath the radical here. So I'm going to make the g of x equal to 4 plus x. Now if I do that, that doesn't mean that my f of x is then the square root of x over x minus 2, because we have this x down here. Because there's these two x's, it makes it a little tricky. So at this point, I know that my denominator, my numerator is taken care of. I know that my denominator is going to come out to be an x minus 2. So I'm going to plug in 4 plus x. And then I need to add something to it to get an x minus 2. So I'm going to go ahead and mark the x's out because there's only one of those on each side. And then I'm trying to find this. So 4 plus what will give me a negative 2. We'll subtract the 4. And that what that I'm trying to find is a negative 6. So I'm going to test this and see. I'm thinking that my f of x should be the square root of x over x minus 6. And here, let's check it out. If I put this 4 plus x in, the top's going to be fine. So 4 plus x minus 6 is an x minus 2, which matches, so I was right. This is my f of x. Number 9, we want to find f of g of h. So I need to take the h and plug it into the g. And when I'm done with that, I need to take that whole thing and plug it into the f. So let's start with the h into the g. So I'm going to move over a little bit here. And so I am going to go and I see an x squared. So I need to plug in that square root of x plus 3 squared minus 6, and this comes out to be an x plus 6 square root of x plus 9 minus 6, so x plus 6 square root of x plus 3. And I need to take that and I'm going to plug it in for this x. So f of g of h of x gives me an x plus 6 square root of x plus 3 plus 8. And then just combining these two like terms, I get an x plus 6 square root of x plus 11. Number 10, apply the horizontal line test to determine whether the inverse function here exists and write yes or no. So I graph this, and it's going to be something like this. And horizontal line test, as you're going horizontally up, do you ever cross more than once? And the answer is no, so it does exist because it did not touch it more than one time. 11, determine whether f of x equals the square root of x plus 8 has an inverse. If it does, find the inverse function stating the restrictions on its domain. So number 11, if I graphed it, it was back like this. So yes, it does have an inverse. So we're going to find that, and we start out by changing the f of x to a y, and then we switch the x and the y. And then in order to get rid of square root, I square both sides. So I have an x squared equals a y plus 8. Subtract the 8. And I have y equals x squared minus 8. And with that being said, I do have some restrictions because I have restrictions on my original one. And you can think of the restrictions, well, if this was a negative 8, which is the lowest it could go, that would be a 0. So for the inverse, it has to be that x is greater than or equal to 0. Now, the only thing I forgot to do, I need to change that back to inverse functional notation, x squared minus 8. All right, number 12. Show that f and g are inverses. So I need to find f of g of x, and if they're inverses, remember, it has to come out that the answer is equal to x. So let's do this. Let's find f of g of x. So I'm going to take the g and I'm going to plug it in. So this is going to be a square root of 4x minus 32 squared all over 4 plus 8. Well, the square and the square root, they undo each other. So I have a 4x minus 32 over 4 plus 8. The 4 goes into each of these, so it's an x minus 8 plus 8, which is x. So yes, they are inverses of each other. Now let's check it the other way just to be sure something crazy is not happening. So we need to find g of f of x. So I'm going to take the f and I'm going to plug it in for the g over there. And so this becomes the square root of 4 times x squared over 4 plus 8 minus 32. And as I distribute, this has become x squared plus 32 minus 32, which is the square root of x squared, which is x. And so yes, definitely, they're definitely inverses of each other. 13, determine if the inverse function exists, and if so, complete a table for the inverse. And so I need to look and see if my y repeats, and it actually does, so my answer is no. It does not have an inverse. 14, I want to graph this and determine whether function's even, odd, or neither. So looking at transformations, it moved it to the left 6. So we'll go back here. And then is it even, odd, or neither? Well, it's neither because it's not reflected over the y-axis, which would be even. It's not reflected over the x-axis. And then it's not a rotational symmetry, which would be odd. Number 15, the end behavior. So if I look at this one and I graph it, I see that as x goes to positive infinity, the function is leveling off. It's actually leveling off the number 4. And then as x goes to negative infinity, it's leveling off over there as well. And it's leveling off at 4. Number 16, write it in set builder notation. Notice these are just some of the first sections of the chapter. So the set of x such that x is greater than or equal to 32. And x is an element of all reals. And close the set. 17, if h of x is this, find h of 10 minus 2x. I need to plug in the 10 minus 2x into here. 16 minus 12 over 2 times 10 minus 2x plus 3. I get 16 minus 12 over 20 minus 4x plus 3. 16 minus 12 over 23 minus 4x. Last problem. It says this is the difference quotient, remember? But it says to find f of a plus h minus f of a all over h. So we're going to go ahead and do them one at a time this time. So f of a plus h, negative 1/4 a plus h plus 6 comes out to be negative 1/4 a plus, or minus, not plus, minus 1/4 h plus 6. Now let's go and find f of a. So I just need to plug in the a, and then I'm going to go ahead and do f of a plus h minus f of a, and I get negative 1/4 a minus 1/4 h plus 6 plus 1/4 a minus 6, because I'm subtracting it so it changes the sign, and then these will cancel out, and I am left with negative 1/4 h, and then I need to go in and divide it by h because at the bottom here, so I'm dividing out the h. That cancels out, and then I am left as my answer with negative 1/4.